Morning, everyone. Good to see you guys today. So I think what we're going to do today is I'll start by doing some review of the lecture 3 homework, and then I want to have some discussion about our project. So have you guys talk a little bit about the articles that you found? I did also find a sexual health attitude scale, I think it's called, or sexuality. I'm trying to remember what it's called. Maybe scale of sexual attitudes. Let me see. Sexual attitude scale is what it's called. So I found that, and that's something we might be able to use if we wanted to look at early sexuality education, or just even sexuality education in public school, and then see how that compares or how that relates to sexual attitudes. So that could be something we could do. We can maybe look at the difference by age, or look at the difference by gender, something like that about sexual attitudes. Or then we could also just divide it up on whether they had sexuality education or they didn't have sexuality education, and then look at their attitudes. So those are some things that we might be able to do. So let's just start by, I know I got articles from a few of you, but I haven't gotten articles from, I haven't gotten abstracts or PDFs from, or links from all of you. And that's going to be part of your project grade. So I need to get at least one appropriate article from you guys. And as we have this discussion today, if you haven't finalized your article, this might help, because maybe you could find an article specifically on that sexual attitude scale or something similar. So is anybody willing to talk about the article they found, and what the article was about? Just a brief synopsis of their article. Anyone willing to do that? I mean, you guys are all going to need to do it, so either today or tomorrow. So
mine was more along the lines of talking about like how it's introduced like in the classroom, and like kind of like the positives and the negatives of it. So like they're like the determination of like whether it's like the good and the bad, and like there was also like some research done in one of the parts of it that explained that there was like a little study done based upon like the effects it had, and just kind of basic information about what exactly it all entails.
So when they looked at, Courtney, when they looked at what effect it had, what were they looking at? Like, what was their dependent variable? What were they measuring to see if it had an effect?
Let me pull it up again real quick.
And then was this primarily like high school or middle school, or did they indicate? Did you already send me your article, Courtney?
Yes, I emailed it to you because I couldn't find like a link
Okay.
to but it was a study that examined 66 comprehensive sexual risk reduction programs. So it was based upon like the programs themselves. I don't think it
Oh,
was
so they were looking at the
individuals.
effectiveness of the program.
Yes.
Was it mostly like just knowledge?
Kind of, yeah. Just kind of like along the lines of like the like it was more so based on like the effects um of the program itself.
So
Um,
did they measure sexual behavior or did they just measure attitudes or just knowledge, do you think?
um, I get well. It there's like actions based upon it. So it was like 40% delayed sexual initiation, reduced number of sexual partners, or increased contraceptive use. Um, so it's like the actions that they took. So they kind of measured along the lines of like how it affected them and the choices that they were making.
Great. So yeah, so in that study, they actually measured behavior. Did
Yeah.
they use contraception? At what age did they have sexual encounters? How many sexual partners did they have? So they were actually showing that the sexuality education was effective to reduce the number of sexual partners or delay for sexual experience, things like that. Very interesting. And just to let you know, Courtney, I don't see an email from you, so you might want to email that to me again.
Okay, I'll try. I always have issues with Blackboard email, so I'll have to try and do it again.
Yeah, or you could just do it outside of Blackboard. Just email it to my email, carol.faust@csupueblo.edu. So if you do that, that could be good.
Okay.
Okay. Anybody else? Thanks, Courtney. That was great. Anybody else want to talk about what they had, what they found?
I did education for adolescents that are on the autism spectrum disorder.
Awesome.
And the purpose was to have like describe the parents' perceptions of sexual education needs of their children, and it was with children that were from 14 to 20 years old, and it said it uses focus groups and telephone interviews for the study,
Great.
and it was just
So
like,
Sierra, what kind
yeah,
of data was that? So Sierra, what kind of data did they collect?
um
If they used
you mean,
interviews and focus groups, were they collecting quantitative data or qualitative data?
that would be qualitative.
Very good.
And it was just to help them transition into adulthood to like avoid sexual risks and have like a good understanding of healthy sexual life.
So did the article make recommendations then on what parents could do to be able to
Um,
um,
I
achieve
think
those
it like
things?
said I think it said that like the parents were the most knowledgeable about how their children learned, and like they suggested the future interventions and for how their child would best understand the topic.
Uh-huh. So their recommendations were, but their recommendations were to, um, so it looks like I have your article pulled up. It looks like they suggested specific topics
Mm-hmm.
and things topics they should learn about, and then topics you probably shouldn't introduce to them. So that was
Okay.
kind of interesting. Um, and then they also collected the fears that parents had about sexuality education. So that was kind of interesting.
Mm-hmm.
And then the format that they would consider for delivery. So they talked about all different kinds of formats like technology based or interactive or written or visual, things like that, group versus individual. So yeah, I kind of did look at that article. It was really interesting. And so they determined that they did feel like it was helpful to do
Yeah.
sexuality education with their adolescents, with the autistic adolescents. Okay, great. Thanks, Sierra. Okay, anybody else want to share just an overview of their article? Nicole?
Yeah, I can. Let's see. So I
Nicole,
found,
did you send me your article?
no, I can send that to you right now.
Okay, perfect. Yeah, it's fine. You could just send it when you get the chance.
Okay.
Just give us a little summary of it.
Okay. Well, I found an article about, it was a quantitative study of a sex positive female sexuality education course. So it's a course that they're teaching to teach students about like empowerment like of their bodies and how like that affects like their views on it like later in life or just overall. So it says like the study is sought to measure the impact of participation in femsex on participants, sexual subjectivity, a multi-dimension construct including sexual body esteem, entitlement to sexual pleasure from self or partner, self-efficacy in achieving sexual pleasure, and sexual self-reflection. So yeah, so they had participants who participated in the study. It was an online survey. Let's see.
So what kind of outcomes did they have?
Let me get to the results section. And this is a study from Colorado State University in Fort Collins.
Okay.
So I also thought that was pretty interesting to find something that close. Let's see. It's a pretty big this is like their entire write-up of their
Right.
study.
So yeah, if you go to the conclusions, it should give you some basic conclusions of what they found in their research.
Okay. So it says that they did a one-tailed Wilcoxon-signed rank test to determine whether changes in participants' scores in the studies after completing the course. So they found that sexual body self-esteem was significantly increased at the end of the course compared to at the beginning of the course. And let's see, the entitlement to sexual pleasure was significantly increased at the end of the course compared to at the beginning. Self-reflection was significantly increased at the end of the course compared to the beginning. Sexual assertiveness was significantly increased at the end of the course compared to the beginning. And then resistance to the double standard was significantly increased at the end of the study. And self-esteem was also significantly increased at the end compared to the beginning.
Very nice. So they did, the inferential test they used was the Wilcoxon. That's basically a qualitative statistical test. So that tells us that they collected some qualitative information about the individuals' attitudes, which is really interesting that the course really helped them decrease double standard and increase their efficacy and their esteem and all of those things. So pretty interesting. And these were these were college students.
Yes.
Yeah. Okay. Nice. Really good. Thanks, Nicole. That's very interesting.
Yeah.
Did they have any details on, did they use specific questions? Did they share those questions, or did they do any kind of survey, or was it more like interviews?
So
Like, I'm just wondering how they measured like the resistance to sexual double standard, or the like the self-esteem, or that kind of thing.
mhm. So what they did was they had two surveys sent out to the students that were enrolled in the course. So they took one at the beginning and then at the end of the course. So a total of 78 students attended the first session of one of the course that was offered. And then
So on the survey, did they share the kind of questions that were on the survey, or they just said they did a survey, or did they use a specific scale, specific like self-esteem scale or sexual health scale or something like that?
let me see if I can.
Yeah, why don't you kind of look through that, and then we can move on to another person. But if they shared something specific that they used that was like a validated scale, that would be helpful.
Okay,
So
yeah,
why
I'll
don't
look.
you look through and see if you can find if they use something specific.
Okay,
Okay, great. Thanks, Nicole.
yeah.
Anybody else ready to share? Jordan or Adriana or Catherine? Okay, Jordan.
So my study was kind of done on the ineffectiveness of the current sexual education system in 3 Asian countries and 2 English-speaking countries.
Okay.
So it was definitely more of a qualitative study.
Mm-hmm.
It doesn't really have too many statistics written into it, except for the rates of the increased rates of teen pregnancy currently, as well as the increased rates of HIV.
Okay, so the article has specifically focused on how a lack of education or poorly done education.
Yes. So it takes each different country, and because it talks about how the World Health Organization has come up with a sexual education program that all of these countries should follow.
Mm-hmm.
But each country kind of has their own homebrew idea of sexuality education. And in the United States specifically, we're all state dependent on our sexuality education, and it's giving us the numbers on teen pregnancies and HIV, showing that these ways of teaching are ineffective, and mostly it covers how these places are teaching about abstinence, not really protection or education on protecting adolescents and whatnot.
So it's mostly talking about abstinence-based or abstinence-only education, or maybe a lack of education, and how that is resulting in some outcomes like higher teen pregnancy rate or higher HIV or STD or STI rates.
Yeah, and it was
Okay.
definitely like country oriented. Each country had their own
Yeah,
education.
and like you pointed out, in the United States, it's interesting that each state makes decisions. Like, I know when I worked in Texas, they are an abstinent-only education state, where most of the districts would only educate on abstinence, would be abstinence only. They didn't provide any other alternatives. So it's very interesting.
Yeah.
Thank you, Jordan. Anybody else, Adriana or Catherine, have anything to add right now? Okay. So I know that the two Rachels will probably be on later, so maybe I'll have them share theirs when they come back, or we can do it tomorrow morning, and I can get Adriana and Catherine to share theirs also. And then tomorrow we're going to need to make some decisions about what kind of scales we're going to use, what we're going to do. I want to share with you the brief sexual attitude scale that I found, just so you can kind of see what it looks like. It's got 4 different scales, and so we could maybe use 1 or 2 of them, because they're really not an additive scale. It's not like you can add all the points up to get an overall scale. It states, the research states that that's not really helpful. But let me do a share screen with you guys and let you see the sexual attitude scale. Okay, can you guys see it? The brief sexual attitude scale. Do you guys see that on your screen? Okay, so in this scale, this is a Likert scale from strongly agree to strongly disagree. So what this does is it actually quantifies somebody's attitude. So this is an affective measure of attitudes, but it quantifies it by putting a number to strongly agree, to strongly disagree. And so what it does is if you put if you put 5 for strongly agree down to 1 for strongly disagree, you can, because a lot of people see Likert scales as a quantified, that like a 1 would be very low and a 5 would be very high, right? We actually can quantify Likert to kind of see how much people agree with things. Okay, some of these will be reverse scored, so we would have to flip and reverse the score because they don't want to ask all the questions the same direction, because then it can actually mess up people's answering. They just sometimes start mindlessly answering. So sometimes these scales have reverse score, and this one actually has a few items that are reverse scored. So it has 4 different, it's got the Likert scale, and it's got 4 different scales. So it has, if we come down, it's got a permissiveness scale, which is questions 1 through 10. So how permissive somebody would be about their sexual behavior. It's got a birth control scale, and that's from 11 to 13. So the first scale has 10 questions. The second scale has 4 questions. The third scale has 5 questions, and that's called communion. And then the fourth scale has, let's see, that'd be 4 question on instrumentality. So there are questions such as, the first question is about permissiveness. So things like, I do not need to be committed to a person to have sex with him or her. Casual sex is acceptable. I would like to have sex with many partners. One night stands are sometimes very enjoyable. So you can see they're all about permissiveness and how much somebody would agree with that or disagree with that. Then you can see the birth control. Birth control is part of responsibility of sexuality. A woman should share responsibility for birth control. A man should share responsibility for birth control. Okay, and then you have the next one about communication, and how sexual encounters are a communication between 2 people, a merging of souls, a very important part of life, intense, that kind of thing. And then the last part is, why do we have sex? So pleasure, to enjoy oneself. It's primarily physical, and it's a bodily function. It's just a bodily function. So those are some, this is a brief sexual attitude scale, 4 different areas that they're measuring. This is a validated scale. I found quite a number of research articles about it. So we could use the whole scale, or we could find, we could just use one of them, like we could just do the permissiveness thing, or we could just do the birth control thing. So we could use just part of it and have that either an average. You can either do an average, or we could do a total. On these, they used averages since they had different numbers of questions. So to get it on the same scale, they made an average for each one of the scales. So that's something we could either do just one of the scales, or we could do more than one of the scales and just look at the average. And then we could look at that and see if there's differences based on males and females, or based on people that had sexuality education versus people that didn't have sexuality education, that kind of thing. So that's one idea too, is what we want to find is something that would measure an outcome. So this is one example, this sexual attitude scale. So what you guys could start doing is looking for some different scales or measures that would be, that we could use in a survey, okay? Nicole, did you find anything in your article? Did they share anything? You're muted.
Okay, can you hear me?
Yes.
Okay. So I found the link to their survey because they just made like their own survey, but it's not pulling it up like when I try to like bring it up in a new tab.
Okay, well, I'm not sure that may not be, it might have some helpful stuff on it. So if you end up getting to being able to pull it up, just share that with me, or you could even just share the link with me when you send the article.
Okay.
Yeah, and then I can go kind of look at it too. And if any of the rest of you could kind of go look and see if there's some kind of scale or some kind of survey that you could gain access to that we could use, because we don't necessarily want to make up our own survey, because we want to use something that's been researched and validated, and we don't have time really to make up our own survey. So we want to find some kind of a scale that's already developed, and then our other questions will be things like, what's your age? What's your gender? We might ask about ethnicity, although we may not get enough people in order to really use ethnicity. And then we're going to ask them whether they have had sexuality education or not. So we're going to have to decide specifically what are we going to ask to see if they've had sexuality education. Like, are we going to say, you know, did you have any classes educating you about sex in school? Or we might ask if their parents educated them. That could also be, you know, we could say, did your parents provide sexuality education for you at home? That kind of thing. So be thinking about those ideas. You know, I'm really feeling like by next Monday, we have to have this, we really got to have this set so I can get the survey into SurveyMonkey, and then you guys can get the link and be able to send it out, you know, maybe by midweek next week, so you can, we can be getting our feedback, okay? Okay, so let's move on now. I wanted to go ahead and go over homework 3, or do you guys want me to go over homework 3? Anybody? Does anybody want me to go over homework 3? If not, I'll just move on, or I can do it later. Okay.
Can you
I'm
show
gonna
how
just,
to like?
pardon?
Can you show how to how we're supposed to do the sampling thing? Like, you know how you convert to where it's the males and the females on Excel?
Okay, say again.
So, So like how you organize the data from where it goes from the male to the females, how you organize that to where it's the males on the top or females on the bottom based upon
Oh,
like the numbers,
absolutely.
like the one of the two.
How we do the sorting.
Yeah, I couldn't like figure it out when I was trying to do it.
Okay, you bet. So let me go ahead and show you that. Okay, so remember on the when we're doing this, so here's our data. Can you see it? Okay, so when we have our data, and I can just go through basically what you're supposed to do really quick. It wanted you to find, I think the very first thing was to find the average age, and then it had you weight the quizzes by 50%. So we had to turn them into, first we had to turn them into percentages. Then we had to multiply each quiz by 0.5 and then add those two scores up and then find an average. Okay, so that's basically what you did for the first part, was convert these to percentages. So if you'll remember to convert them to percentages, you just did, you just say equal and then E4 divided by, it was 15 total points and then times 100. So that converted it to percentage. And then the same thing for quiz 2, equals F4 divided by, and it was worth a total of 20 times 100. So that converted it into a percentage. So then we had our percentages, and then we needed to weight those. So we needed to get a weighting for quiz 1. So all we did there was say equal H4, and then I wanted to multiply that by 0.5. And then I would do the same thing for quiz 2. So that was equal I4, and I wanted to multiply that by 0.5. And then I would have just added those to find my weighted percentage. Okay, so then I would have just said equals J4 plus K4, and that would have given me my percentage, my weighted percentage. Okay, and then all I had to do then is take an average of that to get my average weighted score. Okay, so that was my average weighted score. So the right answer on the quiz was 86, because you had to round. It was 85.58, right? So then I think it asked you, you were asking Courtney about getting this into what you want to do is you want to go to the home screen and you want to go to sort. Okay, so on the home screen, there'll be sort and filter, and then you want to custom sort it, and you want to custom sort it by the column on gender. So what was the column on gender? Oh, right here on D. So I wanted to sort by column D. So then it sorts it into the 1s and the 2s. The males were 1s and the females were 2s.
Okay, see, I did that, but for whatever reason, it was like switching the values around. Cause like I noticed, like I'd look at like say Jim or something, and he'd be okay, but then like whoever's below that, it like the numbers were like getting mixed up and they were changing. So I didn't know
Right.
if I was doing something wrong or.
Yeah, super important that you grab all of the columns. So if
Okay.
you don't get all of the columns, it only sorts the part that you highlighted.
Okay.
So that can cause some confusion. The other thing that I encourage you to do is once you start doing some analysis, I would cut in, or you could even start a new, you could start a new sheet, because if you screw something up, you can't go, it's hard to go back. And then you
Yeah.
just have to start new. So sometimes once I do a little bit of analysis, I'll cut and paste that and I'll do a new sheet. That way, if I mess something up, I can always go back. So that's just another good tip about doing this analysis, especially as we start getting into doing some more complicated analysis. It's good to make sure you're kind of keeping track of steps, so you can go back to an earlier step, just in case. You've seen me do it. I fail to get one of the rows, or you maybe fail to get one of the columns. Then it can mess things up. Okay? Okay, so
Thank you.
always feel free to reach out to me if you're just struggling with something. I try to check my email a number of times a day, just in case somebody is, working on something and they're stuck, or they're getting frustrated. So make sure to reach out to me, and like I can just hop on a Zoom with you and we can go through it, and I can maybe help you figure it out if you're struggling. Okay. Okay. So let's just move forward now. We're gonna now hop into the next lecture. Okay, so let me get that up. So lecture 5, we're going to be moving into the next bit of concepts. Let me make sure I'm on the right screen. Okay. Okay. Are you guys seeing lecture 5? Okay, awesome. Okay, so lecture 5, I'm sorry. Lecture 5 is all about normal distributions. Okay, so remind me, how many of you guys have had a stats class before? Sierra, Courtney, Jordan, Nicole, Adriana, have you had a stats class? No? Okay, what about uh, Rachel and Rachel?
I haven't had a stats class. I only took up the pre-calculus.
Okay.
I took stats, yeah.
Okay, and then what about Catherine? Have you had one? Are you there, Catherine? Okay, she must have had to go do something. Okay, so some of you guys, this will be a little bit of a review, but some of you, it might be somewhat new, but a lot of these initial concepts on the normal curve and variability you had when you were probably in the 5th or 6th grade. Okay, so you probably will be like, oh yeah, I remember some of that at a basic level. Okay, and so we're gonna no worries, Catherine. So we're gonna take it a little bit to the next level. Okay, so the first thing that we have to all be on the same page about is the scales of measurement. Okay, so there are different scales of measurement when we're collecting data. So I talked about this a little bit yesterday. So the nominal scale, these are primarily categories or labels, okay? So like gender, it's a label, gender identity, okay? There's just labels. There's not necessarily a number that makes any sense. Like if you give, 1 to one gender, or 2 to another gender, or if there's another gender identity, 3, it doesn't really make sense. So it's not really a quantitative measure, okay? So, if I ask you what's your favorite sport, You know, some people are going to say golf, and some people are going to say football, and some people are going to say basketball. But I can put numbers to those, but the numbers don't really mean anything. Okay. The words mean something. It's a category. Okay. So some data is considered nominal. It's just a category. Okay. I can put a number to it, but that number isn't meaningful. Okay. So that's nominal. Okay. Now there are some categories that we can put numbers to that do become meaningful. Like I just talked about, the Likert scale, where, you know, 5 would be strongly agree, and, you know, 1 would be strongly disagree. And the closer they are to 5, or the, you know, the more they agree. So it provides meaning because people actually see those Likert scales with equal distance between them. Or even if you did like year in school, where, you know, one is first grade and 12 is 12th grade, there's some meaning to that. There's a year in between each thing. Okay. But there's a lot of categories where the number doesn't mean anything. You know, if I number a bunch of different fast food restaurants, and you say, and I say, tell me your top 10. Okay, the number doesn't really mean anything. I could put 1 on McDonald's just as easy as I could put 1 on Taco Bell. Okay, so that's just nominal data. So we don't do any inferential analysis or differential statistics, descriptive statistics. We don't do anything descriptive or inferential on nominal data. It doesn't make sense. Okay. Ordinal data. This is data that can be actually put in order or ranked. Okay, like we could rank, say there was a race, a 5K race. We could rank who was first, who was second, who was third, who was fourth. Okay, so we can actually put those in order. Okay, but there's not necessarily an equal interval between each runner. Okay, so like runner 1 could finish the 5K in 21 minutes, runner 2 could finish in 21 minutes 15 seconds, and runner 3 could finish in 24 minutes. And then runner 5 could finish in 24 minutes 5 seconds. So there's no equal distance in between. Or I could line us all up by height. And you could have the tallest to the shortest, or the shortest to the tallest, but there might not be equal distance in between. You might have somebody that's 5 foot, somebody that's 5.5 feet, and then somebody that's 5'4", and then somebody that's 5'4" and a 3/4, and then somebody that's 5'6", right? So there's no equal distance in between, but we can tell what the order is. Okay. Ordinal data also cannot be analyzed with parametric statistics, like what we're doing in this class. So we will collect nominal data, but we're only using nominal data to separate our groups, especially with descriptive research. Okay, so we just use it as a way to categorize groups. Okay. So we are going to be mainly dealing with what's called continuous data. Okay, continuous data is data that's ordered. Okay, and there's a interval, a known measurable interval between each data point. Okay, it's data that can be manipulated by adding, subtracting, multiplying, right, dividing. So it's like saying, okay, how many cigarettes did a person smoke? Okay, well, one person smoked 20, one person smoked 10, one person smoked 0. Okay, but I can say the person that smoked 20 smoked twice as many as the person that smoked 10. They smoked 20 more cigarettes than the person that didn't smoke any at all, right? There's an equal distance between each one. Okay, it's called continuous data. We can manipulate continuous data mathematically, okay, where we can't manipulate nominal and ordinal data mathematically. Okay, there's 2 types of continuous data. There's interval data, and this is data that has an arbitrary 0 point. Okay, so it doesn't necessarily have a true 0 point. So for instance, temperatures. You can have, the temperature could be 0, but there's still temperature. Okay, there's still a temperature. Where like, if I use ratio data that has an absolute 0 point, if I'm measuring how many cigarettes someone smokes, there can be 0 cigarettes. There can be no cigarettes, right? An absence, complete absence of cigarettes. There can't be a complete absence of temperature. There's still a temperature. It just happens to measure at 0. Okay, does that make sense? Okay, and we're going to be using interval and ratio data. Okay, so you'll see these, we use continuous data to analyze. Okay, so you just need to know that if we're doing descriptive statistics, if we're doing inferential statistics, we are using continuous data. Okay, it might be interval where there's not really a 0 point, or it might be ratio where there's an absolute 0 point. Okay, questions about that?
So if you were to do like the race scenario and you knew like first, second, third, then that would be the ordinal. But then once you knew like the actual times that they got, then would that become continuous?
Absolutely. So the actual times they got, that's continuous data, and it has a true 0 point, right? I mean, there can be like no time, like somebody could not spend any time on something, right? So there can be 0 time. So the time it took them to do the race is actually ratio data. Okay, where you could say like someone took twice as long as someone else, or someone took half as long as someone else, right? It's ratio data. There's a true 0 point. So yeah, we could put it in ordinal order, but actually the times are much more valuable for measurement purposes, right? Okay, any other questions or comments about levels of data? Okay, I'm going to be relating the levels of data back to the measures of variability, okay? So if we look at, like if we did some differential, I don't know why I keep saying differential. I have differential tuition on my mind. If we did descriptive statistics, if we ran descriptive statistics, so if I had the measures of a bunch of people's, say cholesterol. So here we go. We have all these people, and here's their total cholesterol level, okay? So we could measure some descriptive statistics. What was the mean? What was the standard error? The median, the mode, the standard deviation, the variance, the kurtosis, the skewness, the range. So these are all descriptive statistics. This describes this group of data, okay? And you can see I actually put it in order from the lowest cholesterol score to the highest cholesterol score, which was Bill at 255. So John had the lowest at 138. Bill had the highest at 255. So you can see this is an array of data, The lowest score being 138. So you can see the minimum was 138. The maximum, oh, I'm sorry, there was way more. Harry, the maximum was 370. Okay. So that's the smallest score was 138. The largest score was 370. There's 30 pieces of data. Okay, in this data, the sum doesn't really help us that much, but we do know what the range is. Okay, the range is taking the highest score of 370 and subtracting the lowest score of 138. So I know the range is 232 cholesterol points. Okay, from 138 to 370, that's the range. Okay. So then we're going to talk a little bit more about some of these measures of central tendency, okay? But when you look at an array of score, 138 to 370, you can see that those scores actually fall into a normal distribution, okay? So you can see the normal curve. This data actually normalizes where you can have more people, right? You have people that have the higher, the closer to the average. So if I average the scores, the mean was 238, okay? Which falls right here towards the center, okay? Between 200 and 250, the mean's somewhere right in here. So you can see more of the scores fall around the mean. And then fewer of the scores fall out to the extremes, either the lower extreme or the higher extreme. Okay, so these scores are falling in what's called a normal way or a normal distribution, where fewer scores, like there's only one score at 138 and one score at 370. And then you can see the number of scores increases as you get closer to the average. Okay, that's what we consider a normally distributed array of data. Okay, you can also see it in this bin diagram. You can see that 138, there's one frequency between 138 and to 184, and then between 184 to 230, there's 2 scores. Then there's 11 scores, then there's 10 scores, and there's 4 scores, and there's 2 scores. Okay, and then you can see the cumulative percentage. Okay, the cumulative percentage. There was 30 scores. So one score is about, 0.33. So you get to 0.33%, then 0.1%, then you hop all the way up to 46%, then to 80%, then to 93%. Okay. And then this should actually be 100%. It's not picking up that other 0. Okay, so you can kind of see the distribution there. Okay, you can see it here too, 1, 2, 11, 10, 4, 2. So you can just see that normal curve. It's on its side here. You can kind of see, like if we actually had a bar graph here with 1, and then with 2, and then with 11, and then with 10, and then back down to 4, and then back down to 2. Okay. So this is a demonstration of a group of normally distributed scores. Okay, so what it does is it creates a symmetrical or bell curve. A symmetrical or bell curve. Sometimes you'll hear it called a Gaussian distribution or a bell-shaped curve, where the values are distributed underneath the curve in a typical way. Okay, so we know how the distribution falls in the percentages. Okay, this is assuming that the curve is not skewed or bimodal. So skewed means that, like if it was skewed, the hump would be over here. It would hump over here. If it was skewed on this side, which is actually called a negative skew. If it was skewed over here, say the hump was moved more towards the lower scores, that's considered a positive skew. Okay, the skew always follows the tail. So if my hump was here and my tail came down here towards the positive side, okay, so this is the positive side of the curve, that would be considered a positive skew. If the hump was over here and the tail fell down to the negative side, that would be considered a negative skew. Okay, so that's a skew, and I'm going to go over that again too. And then kurtosis is how pointy the curve is. Is it really tall and pointy, or is it flat, more of a flat curve? That's the measure of kurtosis. Okay. So if it doesn't have a big kurtosis or a big skew, then, and this has a little bit of kurtosis, it's kind of a little bit of a high hump, but this is fairly normally distributed. Okay, so we know that if it's a normal Gaussian curve or a normal curve, the standard deviation defines the variability of the distribution. So what we're going to do is we standardize the raw scores onto the normal curve. Just like we standardized the raw quiz scores into percentages, remember when we did that, so we could compare them? We can standardize raw scores onto the normal curve through the use of standard deviation. Okay, that's why it's called standard deviation. We're going to standardize the scores onto a normal curve with standard deviation. Okay, and we know that one standard deviation includes 68% of the scores. 2 standard deviations has about 95% of the scores, and 3 standard deviations has about 99% of the scores. Okay, so I'm going to kind of show you that visually now, just so you can get a feel for it. Okay, can you guys see the whiteboard? Okay, actually, I'm going to move the whiteboard onto my other screen. Hang on just a second. Okay, can you see just a plain white screen? Okay, so the normal curve is, so if we make a normal curve, okay, this is where the mean's going to be, right in the center, okay? That's where you're going to have your mean of your distribution. Okay, so on that distribution that I was just showing you of the cholesterols, this is right where we would put the mean. I think the mean was 238, is that right? Does anyone have their lecture up? I think it was 238. So I should have got my, let me just write it, 238. Okay, so that's where the mean would go, okay? And then we're gonna have what's called standard deviations, okay? The normal curve has 3 standard deviations on each side, okay? So this would be, this is actually where the mean is, and so this is a standard deviation actually of 0. And then this is a standard deviation of 1, standard deviation of 2, standard deviation of 3, and then this is, so these are all the positive scores on this side, on the right side, okay? And then the negative scores, or what's below the mean, will be on the left side. So this would be a standard deviation of -1, of -2, and of -3. Okay, doesn't necessarily mean that the raw scores are negative. It means the standard deviations are going to be negative. Okay, because we're going to standardize our raw scores of 238 into standard deviation. Okay, so what was the standard deviation of our scores? Let me go back. Let me just look at it really quick. So the
51.
Pardon?
51 or
51
52.
or 52. It was 51.95. So 52. So the standard deviation is 52. Okay? So basically, in order to get the standard deviation for each one of these, we're going to add 52. Okay? So if my mean was 238, and then I'm going up 1 standard deviation, I take 238 and then I add 52. So that would give us 290 at the first standard deviation. Okay? And then I would add 52 more, and that would give us 342 at the second standard deviation. And then I would add 52 more, and that gives us 394 at the third standard deviation, okay? Now to go the other way, I have to subtract. So I would get my mean, 238, and I would subtract 52, and that would be 186. And then I would subtract 52 more, and that would be 134. and then I would subtract 52 more, and that would be 82. Okay. So this, I can plot my raw scores onto this normal curve with the standard deviations using the calculated standard way the scores deviate from the mean, okay? And that's calculated for you by Excel, but you guys are going to learn how to calculate this by hand, okay? So now, we also know what percentage of scores fall on this normal curve, okay? So for each standard deviation, we have a standard percentage of how many of the scores fall. So for the first standard deviation, this is the biggest area. So if you look at this area of the first standard deviation, it holds about 13, it's a little bit more than 13% of the scores on both sides. Okay, so it's 13 point, I think the lecture tells you exactly. It's, oops, not that one. It's 13.13. So 13.13% of the scores in this first standard deviation. So as a total, in the first standard deviation, we've got 68% of the scores. Okay, so 68% of the scores in this normal distribution fall within the first standard deviation. Okay, so 68% of the scores are between 186 and 290 for the distribution. Okay, so 68% of the scores fall here. In the next level, does anyone know what these next percentages are? I'm sorry, I did this wrong. 13% is here. You're probably going, Dr. Faust, that doesn't add up to 68. Okay, this is 34. Okay, so 34% is 68. Then this next area is 13. So if we add 26, it's like 13.6, I think. So if we add these up, if we add all of these percentages up, this is going to give us 95%. Okay, so the first standard deviation, 34%, 34%, it gives us 68% of the scores. Okay, so 68% of the scores are falling between 186 and 290. Then we're adding the next standard deviation. It's another 13% on each side because my normal distribution is decreasing on both sides, so it's a smaller area, okay? So 13%, 13%. So if we add all of this up, it gives us 95% of the scores. So 95% of the scores are going to fall within the first two standard deviations. Okay, 95% of the scores are going to fall within the first two standard deviations. Okay, and then this last area, whoops, this last area, so out here, so we have 5% less left. So we know that there's 2.5% on each side, okay? So in this last little area, you're gonna see about it's like maybe 2.4%, because in this area, to infinity is only about 0.1%. So, whoops. I should have just done that inside. Okay, so this is about 2.4, 2.4, and then this is like 0.1 beyond the third standard deviation. Okay, so if you go to the third standard deviation, we're going to consider that. We're going to just consider that 99%. It's very close to 99%. Okay, so 68% within the first the first standard deviation, 95% within the first 2 standard deviations, and 99% in the first 3 standard deviations. Okay, so it's basically telling us 99% of our scores are falling within 82 and 394. Okay, 95% of our scores are falling within 134 and 392. Okay, so for the sake of statistical analysis in our fields, in health science, in exercise science, in psychology, most of the social sciences, they're going to use a 95% confidence level. So any scores that fall within the first 2 standard deviations, we're going to consider those scores the same, from the same group, from the same population. So these sample scores, these sample raw scores, we're going to say these scores all belong to the same population if they're within the first 2 standard deviations. If they fall outside the first 2 standard deviations, either low or high, and I think we had 1 score on each side that fell outside, or maybe we didn't on the bottom. It was 138, I think. So that score wasn't even unusual. It fell within 2 standard deviations because it was 138. And the second standard deviation here was 134. But we had that, oh, and the highest one was 370, right? 370. So it fell within also. So that whole distribution of scores all fell within the first 2 standard deviations. So let's say that we had somebody get their cholesterol and they had a cholesterol of 110, which would fall down in here somewhere, okay, somewhere maybe like right there. This person would be considered unusual. They would not be considered a part of this group. Or if we had somebody that had a cholesterol of 400, which would be over here, this person would be considered unusual. They're not a part of this group, right here. Okay? Does that make sense? Okay, so let me go back to the lecture. Okay. So you guys need to know, like, you should be able to just draw that curve. Draw the curve, the standard deviations. You should be able to know that 0 is at the mean, 1, 2, 3, and then negative 1, 2, 3. And then you need to know there's 34% in that first standard deviation, 13% in the second standard deviation, and about 2.4% in the third standard deviation. Okay, you should be able to just draw that out. Okay, so what that does is it gives you some, we're going to talk about percentages after a while. So like 50% of the scores are above the mean and 50% are below. And if you added up all of those numbers, you would get to 50% on the positive side, and 50% on the negative side. Okay, so that's going to tell us that we can apply the normal curve for determining unusual events or differences. Okay, so just like I demonstrated to you on that normal curve, an unusual event or an unusual score is a score that falls outside 2 standard deviations in either direction, either outside the the +2 or outside the -2. Okay, it's not inside that 95%. It's on the outside. That's considered unusual. So it could be considered significant, significantly different. Okay, so when you see in an article where they say there was a significant difference and they give you a p value, have you ever seen that? A small p with a little number behind it? That's the probability. Okay, so if it's 0.05 or less, that means that there's a 5% chance or less that 95, those 5% that are on the outside. So that means that it's on, though that data was on the outside, which means those groups are different. They come from different populations. They're significantly different. Okay, so 5 times out of 100, it's falling outside, or sometimes you can also hear it said, we might be wrong 5 times out of 100 too, because this is all a probability. It's just a probability. It's all based on mathematical probabilities. Okay, but when we have those two scores that we're comparing, if they're more than 2 standard deviations away, then we know that, hey, this is different. Okay, because it's unusual. There's a difference between the two groups. So when 2 groups of people are measured on the same variable, the range of scores do not overlap between 2 standard deviations. This is often interpreted to mean that the 2 groups are different from each other in some way. Okay, so if we go back, and we look at our screen share. Okay, can you guys see the screen share again? Okay, so the mean of this group was 238, right? And we know that we've got this whatever it was, 372 maybe? 372 here and 134 here, okay? So if we had scores that were falling outside of that, we would know they were from a different group, okay? We would know they didn't belong to this group. That's how we're gonna analyze that, okay? So we're gonna talk about it from a raw score standpoint, and then eventually we'll talk about means. And we'll use what's called standard error, which is like the standard deviation of error, okay? To actually, we'll be comparing means instead of comparing actual scores, okay? So in this way, we would be comparing individuals, where that's not as helpful as comparing groups of people. Because remember, we talked about with external validity, if we have large groups of people, then we can really compare them. We have enough data to compare that we can then generalize to a larger group. Okay? Okay, questions about that? It's kind of a big concept, but that's the main concept of inferential statistics. That's the primary concept of seeing if there are differences between groups. Okay, it's all probability. Okay, it's all determined by probability of a Gaussian curve, the normal curve. Okay, so yes, Jordan.
Are you able to make the bell curve on Excel? Because I know you can make a bunch of charts and stuff based off of the data. So if you were to do the statistical stuff, can you make the bell curve on there?
Absolutely. So in the lecture, when I showed you the lecture, so let me go back to the lecture. Okay, so this was actually made in Excel. So what it did is it takes all of these raw scores, right? It puts them on a frequency distribution, and then you can actually make a frequency distribution. So you can see this is the actual chart or plotting of those scores. Does that make sense, Jordan? Is that what you were
Yeah,
asking?
I thought you had like hand drawn that. I didn't know that Excel had done that.
Oh, no, no, no. The thing that I drew on the whiteboard, I just drew with my finger. Yeah. But what I'm saying is this is an actual distribution of these scores. Do you see what I'm saying? So is that what you were asking or no?
Yeah, no, I just thought that you had like made that chart. I didn't know that it was on Excel.
Yeah, you mean this one right here?
Yeah.
No, no, I didn't draw this. This is actually made by Excel.
Okay.
Yeah. So if you go in and you do you put the bin levels into Excel. So the bin levels were created. Then if you put those bin levels into Excel, then it will actually draw this for you. Okay, it draws, and you can also do kind of like a histogram. This is basically a histogram. You could also do a bar graph that would give you kind of a feel. So you can almost see this on the side, the bar graph, where it would have 1, then it would have 2, then it would have 11, then it would have 10, then 4, then 2. And so you'd have that bar graph that would show the curve there. Okay, so yes, you can definitely visually demonstrate this in Excel, and it draws it for you. This was done in Excel. I didn't draw this. Any other questions? Okay. Okay, so let's keep going. So you got to get this. This is probably one of the most important concepts in the entire class. Applying the normal curve to determine unusual events or differences so you can make decisions and inferences. Okay. Okay, so these are some of the simple denotations you're going to see. So a raw score, I'll be using a small x for that. So when I'm doing things like your subject score or your raw score is a small x, the subject number is n. The mean score is a large M, or sometimes you'll see the mean a small x with a line over it, or an M with a line over it. Okay, but the mean score, I'll be using a large M. The standard deviation is a small s. The variance is the standard deviation squared. And then we're going to talk about z-scores and t-scores. Okay, so these are all common denotations we'll be using throughout the rest of the class that you need to be familiar with. Okay, so these are the measures of central tendency. These are the things that you probably learned in elementary or middle school. Okay, so these measure central tendency. So the mean is an arithmetic average score. It's adding up all the scores and then dividing by the number of scores there are. Okay, so you guys are all familiar with this. So if we had 5 different raw scores, so here's my 5 raw scores, I could add up all my raw scores. Okay, I have 5 observations, so I would divide by 5, and that would give me the mean. Very straightforward. This reflects the effect of every measure within the distribution. Okay, so if you have 144 as your mean, then you can say, how much does each individual score differ from the mean? Okay, so you've got 144 is the mean, but you have these other scores that are below the mean, and you have scores that are above the mean. Okay, so you can see that scores are distributed along a continuum. Okay, so this can be disproportionately affected by extreme measures. So we've got like 120, 130, 130, 140, and then all of a sudden we have this extreme measure of 200. This can skew our data. It can pull our mean, it pulled it over to that positive side because it's such an extreme score. Okay, so our means falling here, you can see that if we actually plotted this, you know, we'd have these scores coming along here and the means drawn over more to the right, okay? So the actual scores themselves can create some differences in distribution, okay? So the mean is the arithmetic average, okay? And here's the formula, very straightforward. You add up all the raw scores in 1 and 2 and 3, so on, divide by n, which is the number of observations, okay? Or you can denote it this way. This little sigma sign means sum. So the sum of the raw scores divided by n. That would be your formula. The sum of all the raw scores divided by the number of scores, okay? The number of observations. The median. The median is the score that divides the distribution into 2 equal parts. Okay, so it's the very middle score. That's the median. If there are an even number of observations, then you take the 2 middle scores and you average them. Okay, so if you had 10 scores, you would take number 5 and number 6 and you would average them, and that would give you the median. Okay, but if you only have 9 scores, number 5 is the middle score. Okay, so in the case of our distribution of these 5 scores, we put them in order. In order to find the median, the scores always have to be in order. Okay, so you put them in order and you would go to the middle score. In this case, the middle score is 130, so that's our median. Okay. If we had 6 scores, then we would go to 1, 2, we'd go to 3 and 4, and then we'd find the average of those. So 130 and 140, and the average, so then the median would be 135. Okay, so the middle score is the median. It provides a common measure of central tendency, that this is the score that fell right in the middle of the actual raw scores. It's not the average, it's just the middle score when we ordered the scores in order. Okay, and then the mode is the most frequently occurring score. So which score occurs the most often? And in this case, it's 130. 130 occurred twice. All the rest of them just occurred once. So the mode is 130. Okay. If you didn't have any double occurrence of a score, you would have no mode. Okay. Or let's say we had 2 130s and 2 140s. That would be called bimodal. There's 2 modes if they're equal. Okay. Okay, so now these 3 measures of central tendency, they relate back to our levels of data. Okay, so the mode relates to nominal categorical data. Okay, so how often does something occur? So all we are is adding up that this occurred 2 times. That's the most often occurring score, that's the mode. So if I wanted to find out the importance of like your favorite sport, we're using nominal data. Let's say I have your favorite sport to watch and I put 5 sports, you know, golf, tennis, basketball, soccer, and football. Okay. So I would ask people what's their favorite sport to watch. And I would have them say what's their favorite sport, what's their one favorite sport. Okay. Then I would just add up how many footballs are there, how many soccers are there, how many golfs, how many, whatever. I'd add up the number. Well, that is mode. Okay, which one occurred the most often? That's the favorite one. That would be the mode. So the mode relates back to nominal categorical data. Okay. The median puts the scores in order and tells us where the middle is. So it orders the scores, or it's the most meaningful for ordinal data, ordered data. okay? And then the mean is the most meaningful for continuous data. It tells us about variability of data. Where's the average? Okay? And you can only do an average with continuous data. You cannot do an average with ordinal data or with nominal data. With ordinal data, you're just finding a median to give you some feel for, you know, if someone tells me, oh, how about this? I run a race and I go, oh, I was 7th in the race. Does that tell you anything? I mean, it tells you I didn't win, but does it tell you that I lost? No, because you don't even know how many people were in the race, right? You don't know anything about the race. What if I tell you I got 7 out of 2,200 people? That's pretty darn good, right? But what if I told you I got 7 out of 7, 7th out of 7? Not as good, right? I lost. Okay, so you really have to have, or what if I told you I came in 7th and then I tell you the median score was 500? That would give you an idea that 1,000 people, probably around 1,000 people did this race. So I did pretty darn good. Okay. So the median gives you some context for ordinal scores. Okay. The mode gives you context for categorical nominal data. And then the mean gives you context for continuous data. Okay, so you're going to need to know that. Like you're going to see quiz questions about that. Okay, so make sure you understand those differences. The mode is the most commonly occurring score. It's the most meaningful for nominal data. The median is the very center score, or the average of the two center scores, and it's the most meaningful for ordinal data. And then the mean is the arithmetic average, and it is the most meaningful for continuous data. Okay. Some other measures you might see with variability or with variation is the range. That also kind of gives you some context. What is the range of the scores? What's the high, what's the low? And that's all it is. The range is just the high minus the low. Very straightforward. Okay. And then one of the most important measures beyond mean for continuous data is the standard deviation. Okay, so we've kind of been talking about that today. The standard deviation. So what the standard deviation is it measures how much do the scores deviate from the mean in a standard way, just kind of like percentages do. Okay, so it takes each raw score and it compares it in a standard way to the mean or to the average. Okay, it standardizes the raw scores into a standard score. Just like percentage can standardize quiz scores into something that we can use to compare, the standard deviation will standardize scores so we can compare two groups. Just like we could compare quiz 1 and quiz 2 with the percentages, the standard deviation lets us compare group 1 with group 2. Okay, it standardizes it. So what it does in order to standardize the variance is it looks at each score and how much it varies from the mean. So the way that it's calculated, so we can look at figuring the variance first. The variance is figured by taking the mean. We subtract the mean from each raw score. So we take the raw score we subtract the mean. So in this case, here's our 5 raw scores. We're going to subtract the mean. Okay, we got, so 120 minus 44 is negative 24. Okay, these negative scores aren't meaningful, so we have to square them. Okay, so we're going to take our raw score minus the mean. We're going to square that. Okay, so if I take my score 1 minus the mean, I get negative 24. I'm going to square that so we have all positive numbers. And here's my square of the difference. Okay, 130 minus the mean, I'm going to square that. Here's my difference. Same thing, here's my difference. 140, here's my difference. 200, here's my difference. Okay, so these are called the squares. Okay, the squares of the difference. Okay, then I'm going to sum those squares. So this number is the sum of the squares. I'm going to take each square, 576, 196, 196, 16, 3,136, and I'm going to add those all up to get 4,120. Okay, so that's my sum of my squares. Okay, so I've taken each raw score, I've subtracted the mean, I've squared that, and then I summed the squares. Okay, then I'm going to divide that sum of squares by the number of observations minus 1, n minus 1. So we only have 5 observations. So 5 minus 1 is 4. So I would take the sum of the squares, 4120. I would divide it by n minus 1, or 4, and that gives me my variance. And in order to get standard deviation, then I have to take that square back out. So I'll take the square root of the variance, and here's now my standard deviation is 32.09 for this small distribution. I just use a small number of scores so we wouldn't have tons of math in here. Okay? I mainly want you to understand the concept that we're looking at each score and we're looking at how it differs or how it varies from the mean. And then we're squaring that to keep positive scores. Then we're adding those up and we're dividing by n minus 1, the number of observations minus 1, to get our variance. Then we're pulling that square back out by taking the square root, and this gives us our standard deviation. Okay, so then we could plot these scores on a normal curve using the standard deviation. We know that the mean is 144. So 144 would be at the mean, and then we would add 32 for each standard deviation, and then we would subtract 32 for each standard deviation. Okay, so we could do that, and we could find the normal distribution of these scores. Okay, makes sense? Questions? Comments? Okay, so this is the measure, this measures the mean, right? And how each score differs from the mean. Okay, and these scores were actually weights. So in this case, 144 was the average weight, and the standard deviation was 32 pounds. Okay, so we could go back to our whiteboard, and we could put our new scores on here. So our mean was 144. Okay, and then now for this class, you're definitely going to need just like a simple calculator. Okay, because you're going to need a calculator for your quizzes and your tests and that kind of thing. So if you don't have just like one of these really basic calculators, you could actually probably just do it with even more of a basic calculator, or maybe even the calculator on your phone. But if you have one of these, it's going to be really great, just a real basic calculator. So the standard deviation was, what was it, 32? We calculated 32, right? So we would take 144, we would add 32. So the first standard deviation would be 176. Then we would add 32 more. The second standard deviation would be 208. And the third standard deviation would be 240. Okay, and then we would go backwards. We would take the mean of 144, we would subtract 32 and get 112. We would subtract 32 more and we would get 80. And we would subtract 32 more and we would get 48. So we know that 95% of the scores in this population should fall between 112 and 208, okay, from that sample. Okay, now remember that sample had a lot of like 120s, 130s, 140s. They all fell down here, okay? And then it only had that one that was, what was it, 200? Is that right? So if I plotted this, I'm probably going to see my curve be skewed. Okay, so I'm probably going to see, because even though my mean was 144, that's because that high score kind of skewed my mean. Most of my scores were over here, right? In the 120 to 140 range. Isn't that correct? So my actual curve would kind of look something more like this for that distribution, okay? Because my most commonly occurring score of 130 is over here, right? Remember my mode was 130, so it's going to be somewhere in here. So that's my most commonly occurring score. So you're going to see, and I had like a 120 and a 140. So my hump's going to be more skewed. I follow the tail on the positive side. So this is a positive skew. And it was skewed by that score of 200. Okay? Questions? Any questions? Anybody unclear on anything? Okay. So let me go back to the lecture. Okay. So this whole time I've been using raw scores. We got standard deviation. Okay, that's good. So if I have more than one group, this was just one group, but if I have more than one group, I'm gonna convert my raw scores into what's called a z-score. So I can actually plot my scores onto the normal curve. So I won't actually use raw scores on the normal curve. I'll be using z-scores, okay? So I'm gonna convert them into z-scores, and this is also gonna help me see percentages, okay? So a z-score, all it is just, it's like converting a raw score into a percentage. That's all it is. It's very simple. You just take the raw score, you subtract the mean, and you divide by the standard deviation. Okay, so you have to know the standard deviation, you have to know the mean. So you have to know those measures of central tendency. Okay, so I've got to know my raw score. I've got to subtract my mean, and then I've got to divide by the standard deviation. Okay, so for example, I've got a sample mean for resting blood pressure might be 115. Okay, the standard deviation is 20.5. Okay, so if I wanted to make a z-score for this, I would take the raw score of 111, I would subtract the mean of 115, and I would divide by the standard deviation of 20.5, which would give me a z-score of negative 0.195. Okay, and then I can plot that on my z-scale on the normal curve. Okay, so let me just do another example back with our example we've been using on the whiteboard. Okay, so we've got this distribution here where the mean was 144 and the standard deviation was, oh, this was not the standard deviation. What was that standard deviation? 32? Remember those 5 scores that we just did in the lecture? We calculated that standard deviation is 32. Okay, so let's come back to here. So we calculated this standard deviation of 32. Remember, we took each of the raw scores, we subtracted 144, and we divided by, right, the number scores to get the standard deviation, the n-1. Okay, so once we have the standard deviation, then I can do a z-score. Okay, so my z-score, I'm going to take my raw score. So what was one of the raw scores? 120 or 130? Yeah, okay, so let's use 130. So we had a raw score of 130. We're going to subtract the mean of 144. And then we're going to divide by the standard deviation of 32. Okay, so if I do that on my trusty calculator, 130 minus 144, and then I divide by 32, I'm going to get negative 0.4375. So 130 would, okay, so here's 0, right? This is 0, and this is negative 1. So negative 0.4375 is going to fall. This would, right in the center would be about negative 0.5, right? Negative 0.5, negative 1, negative 1.5, negative 2. So 130, I got it pretty close when I guessed, right? It's going to fall right in there at like 0.43. I can plot it. Like I was maybe a little high. It's maybe right here. Okay, so that's where that raw score is going to fall, at negative 0.4375. Okay, makes sense? So the reason we would even do this is because if we had another distribution of weights and we had another, let's say we had another group and we got their weights and we found out that their average rate was 159, okay, and we found out that their standard deviation, so this was the, pardon me, the mean on this group was 144. Okay, and let's say the mean on this group was 159. And let's say the standard deviation on this group was 20. okay? And we figured that by taking each raw score, subtracting the mean, okay? Squaring that difference, summing the squares, right? Dividing, we get our standard deviation, okay? So we got our standard deviation, so we can now plot this. So this would be 159, then this would be 179, and then this would be 199, and then this would be 209. Okay, this would be 139. All I'm doing is adding the standard deviation and then now subtracting the standard deviation. For each standard deviation, I'm going to subtract that amount. Okay, 119 and then 99. Okay, so this is the distribution of these raw scores, and this is the distribution of these raw scores. We can't directly compare the raw scores. We have to put them into z-scores. Okay, so let's say that on this second distribution, somebody had a weight. So they say they had the same weight, 130. So 130, and I'm going to subtract the mean, 159, and I'm going to divide by the standard deviation, 20. So if I do that on my calculator, 130 minus 159 divided by 20. So that is a score of negative 1.45. So negative 1.45, about halfway. Okay, so if I'm in the first group and I have a weight of 130, here's where my score lands in the distribution. If I am in the second group and I have a score of 130, here's where my score lands. So I can actually compare these two. Even though they're the same raw score, they fall at a different percentage, a different percentile. Okay, this score, if we follow this up, right, this negative 0.4375. Okay, now remember, what percentage is the mean? At what percentile would the mean? What percentage of scores fall below the mean and what percentage of scores fall above the mean?
50.
50, right? So this is the 50th percentile, right? If we're doing percentages, this is the 50th percentile, okay? So there's actually a chart that will convert the z-score into a percentage. It will calculate the z-score, convert the z-score into a percentage. So we know that 0.4375 falls below the 50th percentile. So does, oops, I forgot to put the z over here. The z over here was equal to negative 1.45. Okay, so we know that both of these scores fall below the 50th percentile, right? We just know that because they're negative. If you have a negative z-score, you know it falls below the 50th percentile because it's a negative. So if this is 0 and this is -1, -2, -3, these are all going to be between 0 and 50. And then these z-scores are going to be between 50 and 100. Okay, so we know these fall below. Okay, so someone jot these scores down because now I'm going to go to the z-score table so you guys can see that. So jot those numbers down. Okay, so I'm pulling it up. Maybe. Okay. Okay, so here is the Z-score table. Okay, can you guys see that? Okay, so this measures the negative side. This is a negative Z-score table. So this measures the negative side of the Z of the normal curve. Okay, and it basically just acts like a map. Okay, the Z-scores are over here, but then this is the, so this is 3.400, 3.401. Okay, are you with me? So what were our scores again? What was the first one? Negative. Someone help me out. I asked you guys to jot the scores down so I don't have to go back to the whiteboard and look at it.
Isn't it just -3?
No, the two Z-scores that we just calculated. One was negative 1.45. What was the other one? Have I just completely lost you guys? Okay. Let's go back to the whiteboard.
Oh, I don't think I was able to see it because the side portion was blocking it off.
Okay, so this Z-score was negative 1.45.
Yeah.
And this Z-score was negative 0.4375.
Oh, yeah, see, we can't see that because our little screen things are blocking it.
Can you see it now?
No.
Oh, so you guys aren't seeing the whole screen?
I think you could drag the little videos down to the bottom of the screen, and then you could do the, like wide.
I'm sorry, Sierra, say again.
I said you could like drag the little video column down to the bottom, and then it should show like the whole screen for everybody, or more of it.
Yeah, you might have to get rid of your video while I'm doing the screen share. Okay, so let's go back. So we know that the Z-score for the first group, we figured we got a Z-score for the raw score of 130. 130 minus 44 divided by the standard deviation of 32. So this is the mean. So we took the raw score, we subtracted the mean, that's how much it varied from the mean, and we divided by the standard deviation. This gives us a Z-score, okay? The Z-score was a negative 0.4375. So that raw score of 130 falls right here on the normal curve, right where this dotted line is, okay? For the other distribution that had the mean of 159 and the standard deviation of 20, okay? We found the Z-score for the same raw score, 130, subtracted 159, which was the mean, divided by 20, which was the standard deviation. That gave us a Z-score of negative 1.45. Negative 1.45 was right here. Okay, so you found that by going to -1 and then about halfway, 4.5. Okay, so now, and then I asked you to jot that down. Jot down the negative 0.4375 for the first Z-score, and then the negative 0.145 for the second Z-score. Okay, now we're going back to the table. So now we'll go to the Z table. So here's our Z table, okay? So the first one was negative 4.375, is that right? Negative 0.4375. So Since this is the negative side, this has all the negative z-scores, okay? There's another chart for the positive, it's right here. Here's the positives, but we're gonna use the negative side right now. So we're gonna go to -4, was 4375, right? So here's -4, but then we have to go to the -4, and then we're gonna do the 3.75. So if I go, this is the distributions from the left, okay? So this would be a 3.4, this would be a 3.41, 0.2, okay? So this is a -4.3, okay? So -4, and then I would go over to 3, okay? -4.3. Am I on 3 or 4? I'm on 3, okay? So -3.4. So here we are. Here's our percentile, 0.3707. So that's the 37th percentile.
One up. It would be 0.3336.
Oh yeah, I'm sorry. I got to 0.3. Yeah, negative. So we're at the 33rd, almost the 34th percentile. We're almost at the 34th percentile. Okay, so jot that down, 34. Do you guys see that? To get a percentage, we would multiply it by 100. So it would just move the decimal point over. So it'd be 33.72%. So we're at about the 34th percentile. Then the other z-score was a -1.45. 1, 2, 3, 4, 5. So that would be at the 7.35 percentile. We would move the decimal point to, so about the 7th percentile. So we've got about the 7th percentile for the one, and we've got about the, what was it, about the 34th percentile from the other. Okay, do you guys see how I found that? Okay, so for the first one, I just went down to 0.4, and then I went to 3, or you could maybe even go to 0.4, since it was 0.4375, right? So it's right there at about the 33rd percentile. Okay, and the other one was 1.45, so it was at the 7th percentile. Okay, so then if we go back to our normal curve with our data on it, then we see that this was at the 34th percentile. So what that means is that 34% of the scores are below this, right? So that was at the 34th percentile. So this means that if you scored 130 in the first group, your weight is higher than 34% of the people. Okay, 34% of the people have a lower weight than you. Okay, you scored at the 34th percentile. But if you were in the second group, you were at the 7th percentile. So here was your score right here. That means 7% of the people scored below you. So, and that kind of makes sense, because this is 2.4, this is 0.1, this is about 2.5%. And then, you know, maybe you got, if you took this amount, you could easily see that's another 4.5%. So that kind of makes sense that that's at the 7th percentile. So if I scored 130 in this, if I weighed 130 in the second group, I only weighed more than 7% of the people. That means 93% of the people weighed more than me. So if I've got 7% below, then that means I've got 93% above that score. If I've got 34% below, that means I've got 66% above. Okay, so you seeing that? So if I give you a Z-score, you should be able to know, like if someone scored a Z of 2, they would be at the 97th, almost the 98th percentile. So a Z-score of 2, if we go back to the, chart, I came on the positive side because now I've got a Z-score of positive 2, and I go over 2.0, I'm almost at the 98th percentile. Okay? So then I can look at my my data and see that if I'm at the positive 2 standard deviation, that means that 98%, right? 97 point something, right? So that means that I've got about 97.5. I've got about 2.5 above me. Okay, because this was at about 97.5, 97.8. So I've got about 2.5% above me, and I've got 97% below me. Questions about finding percentages, percentiles with a Z-score?
Did the 7 just come from the half of the 13? Is that what you learned? Or where'd the 7 come from?
The 7 percentile?
Is it from half of the 13?
No. It's from the Z-score. So
Okay.
remember, we had a Z-score of negative 0.4, almost 4. So we went to negative 0.44. Oh, it was the 1.45. I'm sorry. We had a 1.45. So we went to 1.45, and that was the 7th, about 7.5 percentile.
Okay.
That's where the 7th percentile came from. Who asked that? Rachel?
I did.
Rachel?
Courtney.
Courtney. Does that make sense, Courtney?
Yeah.
Yeah, you have to find, in order to get to the percentile, you have to find it on the table, and then you plot it on the normal curve. Okay? Sierra? Did you have a question? Okay, so remember, once I know my normal curve really well, so once I really understand that, you know, this is the 50th percentile, let me start again. So if I do a normal curve and I know that this is the 50th, I'm at the 50th here, and I know these percentages, so I know that 34% is here, and I know that 13.5% is here, and I know that about 2.4 is here, so that's about 13 point, I think it's actually 13.6. And I know that 2.4 is here, okay? So these are all percentages. So I know that, like, if I added the 2.5, so if I came up to here, I'm at about 2.5%, right? Because below here, if I go down this way, that's 2.4, about 2.5% is below that. Then I could add another 13.5. So if I took the 2.5 and I added another 13.5, that's going to take me to about 16%, right? At that first standard deviation. Then if I add another 34%, that takes me to the 50th. So if I'm at 2.4 here, I'm sorry, if I'm at 2.4 here, and then I add another 13.5 here, then I'm at 16. Then if I add the 34 to here, then I'm at 50. Then if I add another 34, I'm at the 84th percentile because that I added this 34. Then if I add another, 13.5, then I'm at the 97.5 percentile at the second standard deviation. And then, I'm at 100 up here. Is that making sense? So you just got to know this stuff really good. And that way, like if somebody were to just tell me, if somebody were to give me and they were to say, you've got a z-score of positive 1.0, I know right off the bat, I don't even have to look at the chart. I'm at about the 84th percentile. Okay? If I look at the chart, I can get the exact. I think 1.0 is, it's 84.13% if I look at the chart. Okay? But I can eyeball it by just knowing, like if someone told me, oh, you've got a z-score of, negative 1.0, then if I went to negative 1, I know I'm around the 16th percentile. Okay, so you just got to kind of get to know this normal curve really well, right? Because that's really the basis of what we're looking at. Okay, so let me go back to the let me go back now to the lecture, and let's kind of finalize where we're going to take a break here. Okay, so if we're back at the lecture, after we figure up the z-scores, then we need to be able to determine the percentiles with the chart. Okay. And I'm gonna be sharing with you the URL for that chart, so you'll be able to look it up really easily online. Okay, so I think that's where we're going to stop today, and we'll finish up talking about t-scores and sample means tomorrow. Okay, and I'm going to do a little bit of review tomorrow too, and then we'll have to jump into the homework. Okay.
Will we talk more about our projects tomorrow as well?
Yes, let me, I'm trying to get back to, okay, yeah, so tomorrow, for those of you that didn't get the chance to share your article, you'll be doing that tomorrow morning. And then, I want you guys to really see if you can find some scales, because we're going to have to use some kind of validated scale on our survey. So maybe I'll also share with you the brief sexual attitude scale. You could go look at that and see what you think. And then if anybody else could find a scale, that would be awesome, because we want to use something that's already developed. We don't have time to develop questions that are validated questions, okay? So if we can find some validated scale, like this brief sexual attitude scale, I'll send you the URL for that too, so you can go and look at it. Be looking around, maybe do some internet searches for that. But I think we need to finalize, for sure by Thursday, we've got to finalize what we're doing for our variables. And so then I'll go in this weekend, Friday or Saturday, and make the survey. Okay? Okay, so today's Tuesday. By the end of the day, you have to have your discussion done. Okay, so you must get your discussion done by the end of the day today. Okay, there's no quiz or homework today. That won't be due until, I think it's due the end of the day on Thursday, because we're going to take 2 days on this lecture. Okay, so today the discussion is due, and you also need to send me your article and look for some kind of a scale, some kind of a sexual attitude scale or something around behavior, something like that, that we might want to measure to do with whether you had sexuality education or not. Okay?
So I'm looking at the syllabus calendar right now,
Yep.
and it does say that quiz 4 and homework 4 are due today. So we just moving that to tomorrow?
Oh, I was thinking already 5. No, 4 you do have to do on the sampling.
Okay.
Oh, thank you, Rachel. I really appreciate that. Yeah,
Oh yeah.
this quiz, the quiz for 5 isn't going to be until 2 more days. So yes, you still need to do your sampling stuff. You still need to do your sampling homework and your sampling quiz.
Okay. I just wanted to make sure.
Okay, yes, you still have to do that. I'm so sorry. So if you haven't already done it, quiz 4, homework 4, and the discussion. And then I've got readings and videos for you to watch too. If you're not doing well on your quizzes and your homework, you need to read and watch those videos. Okay, you've got to keep getting these concepts into your head. So if you're finding yourself struggling a little bit on the homework or on the quizzes, go and watch those videos, okay? Read the book, ask me questions. Okay, it's really important that you do that. So you're not just getting, further and further behind. Even if you don't do well, but once we go over it, you go, oh, okay, I get it. That's awesome. To me, that's super valuable. But if after we go over stuff, you go like, I don't know what you're talking about, I'm really lost, you have to tell me. Because if you're getting lost now, then you're going to be lost for the rest of the class. And we don't want that. We want you to be able to stay up and have an understanding of what we're doing. Okay, so these are the times to reach out to me and say like, hey, can we talk quick? And I'd like to do that. Okay, so I can make sure I'm getting the concepts well. Okay, so I'm gonna stay on. I know there was a couple of people that weren't here when I went over stuff at the beginning of the class. So if you still would like to do a little bit more review around the weighting grades and the homework 3 or the quiz 3, you can stay on and I'll kind of go through that again and answer some more questions. If you're not feeling like you need any more on the weighting grades or sorting or figuring those things up or doing formulas, then you can go. Just make sure you do discussion 2, quiz 4, and homework 4 by the end of the day. Okay. And then, maybe try to do a little bit of research on measurement scales for sexual attitudes or sexual behavior. Okay. Okay. I was glad to see you today. I'll look forward to seeing you tomorrow.
I had a question really quick regarding those articles.
Sure.
If we already turned in an article, but we find another one with a survey on it, do you want us to send you those as well?
Absolutely. And if you do that, that's going to help your project.
Okay, perfect.
That will help with your project score.
Okay, awesome. Thank you.
Sure. Okay, so let me know, Courtney, Sierra, Rachel, you guys are left. So do you want me to go back over homework 3 again?
I was just gonna say after you emailed me back, it made sense. So I'm good now. So thank you for that. Because I was just confused on those two, but now it makes tons of sense. So
Yeah, and so Rachel, the mistake that you made was you went in and just divided it by the total number of items instead of weighting it.
Yeah, I saw that, and yeah,
Yeah,
In
so
the chat.
so make sure, so a real common thing that happens is that you got to go back and make sure you really look at the instructions, because I tell you exactly what to do. So just do exactly what the instructions say, and then you'll have a lot better chance of coming up with the answer.
Okay, cool. Cool.
Okay, so
Okay,
anything else that you wanted to ask, Rachel?
no, I think that's it. I took homework for and quiz for yesterday too, and I did good on the homework. The only one I got wrong was I just wasn't thinking clear. Like I did all the Excel functions right, but then it was like it was almost like a quiz question where it was like which one's just like the least one, and I just wasn't thinking, like my brain just wasn't there, so I got that one wrong. But
Okay.
other than that, the Excel stuff makes sense. So I
Okay.
think I got that stuff. And then
Okay.
is quiz and homework 5 going to open today or is going to open tomorrow?
I can open it today,
Okay.
but
Cool.
it's not going to be due until, I think I'm going to make it due the end of the day on Thursday.
Okay. And then is the midterm that's due on Sunday, is that going to be more like the quizzes or more like the homework?
More like the quizzes.
Okay. And
It'll
then
be all multiple choice.
okay, cool. And the time limit, is it going to be similar to the quizzes? Because sometimes I find on the quizzes I'm like scrambling a little.
Yeah, it's well, yeah, it'll be fairly similar.
Okay.
It'll have 50 questions, and I'll probably give you, like, even on the quizzes, I give you a couple of minutes per item. So I'll probably put it for like 100 minutes.
Okay, awesome. Those are my questions. Thank you
Okay.
so much.
Okay. Thanks, Rachel.
Bye.
Bye. So Courtney, what questions did you have?
I just wanted to see if my emails had gone through, because
Well,
even yesterday too, I had emailed you about the quiz and stuff too, because when I took it, the first one scored it, and then the second one said that it was done late. However, I did do it on time by the end of the day.
oh yeah, I got that email and I went in and I fixed it. So your grade should be there now.
Okay, so you just weren't able to see the link that I had for the article there?
Yeah, let me just look really quick to make sure I got your email. Yes, I got it.
Okay, so it was attached to that, but I sent 2 of them. Because the first one was about the quiz, and then I had the article attached, which I sent last night, and then I sent one not too long ago with the article.
Let me look, let me do a search to see what I have from you.
Okay.
Yes, so I've got one that's called, let's see. Oh, so I sent you an email that said, I fixed it. And you said, thank you.
Okay, I think that was an older one.
Okay.
'Cause it happened again.
So all I have is the one you sent today at 10:43.
Okay.
That was the Advocates for Youth fact sheet.
Because yeah, I sent one last night because it happened on the quiz 3 again. So it was coming up late. So I don't know if like the time was like not like set right, or because it happened to that one as well.
Yeah, I don't know. It's really weird because like everyone else didn't have a problem, but let me look really quick. So can you see that it's fixed on your end?
Let me check.
So it was for the quiz.
Yes.
Yeah, so I have it fixed. You got 100%.
Okay. Let me see. Okay, yeah, now it's showing as that.
Okay.
Okay.
Yeah, I don't know why it's doing that to you, because it didn't, I don't think it did that to anybody else. And I went and checked the time, and the time was correct on it. So I don't know if for some reason it's just not logging, it's not logging it in a
Yeah.
timely way. But just let me know if it happens again, because I can always go in and look. Like, even if it gives you 0 points, I can look and see, like, it has the time on there, and then I can see what you answered. So just let me know if it happens again.
I'm sorry about that. Yeah, I don't know what's going on with it, but
Yeah, I don't know either, but I've given up trying to understand everything about technology. I just try to work with it.
yeah, I struggle so much with the Blackboard email, and like, because that's why I always like, I'll send like multiple emails to see if teachers and stuff get them, and they'll be like, no, and so like I have to do it through my phone through Outlook instead, and then usually that works, but I figure it'd work either way.
Yeah, you would think it would, but I think sometimes based on, your like even what search engine you're using, even if you're using like Firefox versus Chrome versus Explorer, it can even change how your Blackboard works.
But yeah, that's technology is just crazy.
Yeah, I also found that if I dump my search history or my cookies, like when I'm using Chrome, if I go in pretty regularly and dump that history, my Blackboard tends to work better.
Oh really? Maybe
So you
I'll
might want to try that too.
definitely try that. But thank you.
Okay, we'll see you tomorrow.
Have a good day.
Okay, you too. Bye-bye.